Hi students, welcome to engineering graphics class. Isometric projection isometric views of plane objects. Let's take a rectangle in elevation. A dash, B dash, C dash, D dash, any dimension. A rectangle seen in the elevation, A dash, B dash, C dash, D dash. We are going to draw its isoview. What you do is, this vertical axis actually extend upwards also. Okay, the vertical axis extend upwards also. We can draw this isoview of this rectangle either in these two planes constituted by these two axes, or between these two axes. I draw it to this side, this plane. I draw a vertical line, then I draw a 30-degree line. This axis, this is this axis. Take the corner B here, take the distance B dash, C dash and mark here. I take the distance A dash, B dash and mark here. Through A, draw a line parallel to this. Through C, draw a line parallel to this. You get a parallelogram. What is this? This is the isometric view of this rectangle visible in the elevation. How do you take the dimensions? Capital AB equals A dash, B dash. Capital BC equals B dash, C dash. Again, the other two are parallel lines. They are also same as this. This is how you draw. So when did you draw? You drew with these two axes. This axis as corresponding to x-axis, this axis corresponding to y-axis. Now I draw it in the other plane. This axis y-axis and this as x-axis. What I do? I draw the vertical line, this vertical axis, and the 30-degree line in this direction. 30 degrees. Agreed? I choose A here. I choose this A here. Take the distance A dash, B dash and mark to get B. Take the distance A dash, B dash and mark to get D. Draw parallel lines. I get to C. This is the isoview of this rectangle visible in the elevation drawn to the other side. I hope you understand. Very simple things. Now, let's draw the isoview of this same rectangle seen in plan so that these dashes will disappear. ABCD is the plan of a rectangle visible in plan. Let's see how they are drawn. Rectangle seen in plan. We have already seen rectangle visible in the elevation. When you draw them in the plan, which are the axes to be taken? These two 30-degree axes. These two 30-degree axes are to be taken. Y-axis doesn't come into play because when you see a rectangle in the plan, it is in the existent plane. There is no question of y-axis. So the question of y-axis doesn't arise. This is the y-axis. Question of y-axis doesn't arise. X and Z. I choose B here. Take C. Take A. Draw parallel lines. I get D. This is the rectangle. Isoview of the rectangle ABCD seen in plan. Now I take the other two axes. I took this as x-axis. Now I take this as x-axis, so that I take B here, A here. Oh, sorry, that is done there. I take A here, B here, D here, and complete it. ABC. 30, 30. So what is this? This is the isoview of the rectangle seen in plan. Agreed? Isoview of the rectangle seen in plan drawn to one side, isoview of the rectangle seen in plan drawn to the other side. Now, you are drawn isoview of a rectangle seen in elevation and seen in plan. In 4 drawings you have made, 2 there and 2 here. In all this, you can see the lengths along the x, y, z axis are maintained along the respective isoaxis. I repeat, the lengths along x, y and z are maintained correctly, same in the corresponding isoaxis. Cartesian coordinate axis x ilum y ilum z ilum dimensions adhe corresponding axis ilude correct aayittu edutittundu thekkichittilla correct aayittu. So lengths along axis are maintained. Axis ekkulla length correct aanu. Then what about the angles? The angles are 90 degrees here and they are different here. They are changing. That means the angles are not maintained. Angles become either 90, either 60 or 120. I don't bother about the values. What we mean to say is the angles are not maintained, whereas the lengths along axis are maintained. Agreed? Now, let us consider the diagonals. If you draw the diagonals here are different. Here the two diagonals are same. Here they are different to each other and also not same as this. ഇവിടെയുള്ള ഡയഗണൽസ് ഇങ്ങോട്ട് വരുമ്പോൾ ആ ഡയഗണൽസും ഈ ഡയഗണൽസും തമ്മിൽ വ്യത്യാസം ഉണ്ടാവും, ഇത് തമ്മിലും വ്യത്യാസം ഉണ്ടാവും. ഇവിടെ രണ്ടും സെയിം ആണ്, ഇവിടെ രണ്ടും സെയിം അല്ല, അത് മാത്രമല്ല അത് ഇതുമായിട്ടൊരു ബന്ധമില്ല. സോ ലെങ്ത്സ് എല്ലാം ആക്സിസ് ആർ മെയിൻറ്റെയിൻ, ആക്സിസിലുള്ള ലെങ്ത്തുകൾ മെയിൻറ്റെയിൻ ചെയ്യും, മറ്റെല്ലാ ലെങ്ത്തും ഡിഫറെന്റ് ആയിരിക്കും. ഓൾ അതർ ലെങ്ത്സ് ആർ ഡിഫറെന്റ്. ദാറ്റ് ഈസ് എ പെക്യുലാരിറ്റി ഇൻ ഐസോമെട്രിക് പ്രൊജക്ഷൻ. അപ്പോൾ റെക്ടാംഗിൾ സീൻ ഇൻ എലിവേഷൻ പഠിച്ചു, റെക്ടാംഗിൾ സീൻ ഇൻ പ്ലാൻ പഠിച്ചു. അതിൽ നിന്ന് രണ്ട് കാര്യങ്ങൾ മനസ്സിലാക്കി. എന്ത്? The lengths along axis are maintained, all angles are different. Axis ആയിട്ടുള്ള ലെങ്ത്തുകൾ സെയിം ആണ്, ആംഗിൾസ് എല്ലാം ഡിഫറെന്റ് ആയിരിക്കും. Okay, now let us see a triangle in elevation. Let us see a triangle in elevation. Triangle in elevation first. Okay, let's draw some triangle. I draw this triangle, some distance, any distance, no problem. A dash, B dash, C dash. What is A dash, B dash, C dash? A dash, B dash, C dash is a triangle seen in elevation. Elevation. You know this length. If you draw the two axes, I draw this vertical axis, this 30-degree axis. I can choose B here, I can choose A here. Now, this BC is not BC here because this is not along the axis. This AC cannot be taken there because it is not along an axis. So what do? You inscribe this in a rectangle. Which rectangle? Some rectangle, A dash, B dash, C dash, D dash, E dash, so that one side of the rectangle passes through C dash. Agreed? Reproduce the rectangle here. B, D, E. What is ABDE? ABD is the isomorphy of this rectangle ABD, A dash, B dash, D dash, E dash. This D is equal to this D. This D dash, E dash is equal to this D. Where is C? Measure this distance and mark C. DC equals C dash, D dash. I hope you understand. Connect them. Connect A to C, C to B, A to B. What is ABC? ABC is the isomorphy of this rectangle, this triangle, isomorphy of this triangle seen in elevation. You can draw them or draw that to the other side also. A, B, D, E, C, agreed? So this is a triangle seen in elevation. This also is a triangle seen in elevation. Now you can draw the triangle seen in plan. What you have to do? You have to simply remove these dashes and then draw once again. Triangle seen in plan. What you have to do? Draw the two 30-30 axis. No question of y-axis. Choose B here if you want. Choose D. This is A, this is E, C, 30, 30, DC equals small cd. Again, you can draw to the other side. A, B, D, E, C, ABCD. ABCD is the triangle seen in the plan. Agreed? What I mean to say is, you can draw this to one side or in this plane or on the other plane. From now onwards, we will draw them to any one of the planes. Either in this plane or in this plane. When you see something in elevation. When you see something in plan, you can draw them with this axis as x-axis or this as x-axis. So we will draw only one of them. Okay, it is very clear to you now. The next task is to draw a polygon in elevation. Let us draw a polygon in elevation. Why do we draw these simple plane objects? We draw these plane objects to give us basic concepts. These concepts will be used while drawing difficult objects. This is A dash, B dash, C dash, D dash. This is a polygon. This is a polygon in elevation. Polygon in elevation. Okay. A dash, B dash, C dash, D dash is a polygon in elevation. I inscribe it in a rectangle. So that D dash pass through that. A dash, B dash, C dash, D dash, E dash, F dash. A dash, B dash, E dash, F dash is the rectangle which contains the polygon. 2 points of the polygon are already here. 1 point is here. Through C dash, draw a vertical line and a horizontal line. And name this P dash and name this as Q dash. Agreed? And reproduce ABEF. How do you do that? I take this as y axis, this as x axis, 30 degree axis. A, B, E, F. On that you can very easily locate D. This D is equal to this D. Take this point P. Take this point Q. Through P, draw a vertical line. Through Q, draw a line parallel to AB. What do you get? You get C. Connect A, B, C, D. What do you get? You get the polygon. PE equals capital PE. This PE is equal to what? P dash E dash. This EQ is equal to E dash Q dash. That's the basic dimension with which we draw this. So this is a polygon in elevation. And this is a polygon in elevation. This is its iso-view. Next we will draw a polygon in plan. Polygon in plan. When you see a polygon in plan, you can instead of redrawing, I manage this ABCD. ABCD is the polygon. Inscribe it in a rectangle ABEF and draw its iso-view. How do we draw? Draw these two axes. 30 degree, 30, 30, 30 axis. 30, 30 axis. 30, 30. A, B, F, E, A, B, E, F, D, P, Q. Draw parallel lines. C. Connect them. ABCD. ABCD is the iso-view of this polygon seen in the plan. ABCD is the iso-view of this polygon seen in the plan. So what we have learned? We have learned iso-view of a rectangle, iso-view of a triangle, iso-view of a polygon seen in elevation as well as plan. Next is iso-view of a circle. Iso-view of a circle seen in elevation, and then we will draw iso-view of a circle seen in plan. Let this be a circle. Let this be a circle seen in elevation. What do you do? Since there are no visible edges to mark along the axis, we inscribe it in a square. Square side is equal to the diameter, you know. So this is the square. This is the square which contains the circle. I call it 1 dash, 2 dash, 3 dash, 4 dash. Agreed? Then I keep a scale and find these 2 points which lie along the diagonals of the square. 4 points lie on the sides, centers of the sides of the square. Squares in the sides in the center of the circle in the 4 points. Where 4 points diagonal full scale which mark. Now you mark them. What is this? This is A dash, B dash, C dash, D dash, E dash, F dash, G dash, h dash. I hope you understand. Now, what we do is draw a vertical line through f dash and h dash, and a vertical line through d dash and b dash, horizontal line through h dash and b dash, horizontal line through f dash and d dash. Mark here 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Agreed? Forget the circle. Think of the square. Reproduce the square. Vertical axis, 30-degree axis, one dash, sorry. 1, 2, 3, 4, 1, 2, 3, 4. Centers A, C, E, G. Agreed? Take this small distance 1 dash 5 dash. Mark 5, same, 6, same, 7, same, 8, 9, 10, 11, 12. Now what? Connect them. 12 to 7, very light lines. 8, 9, 6. What is this? B, D, F, H. Connect them. Connect which all? A, B, C, D, E, F, G, H by a smooth curve. You get what? You get an ellipse. You get an ellipse. Isomeview of a circle seen in elevation is an ellipse. Agreed? Similarly, if you see that circle in the plan, what you have to do? You have to draw these two 30-30 axes. 30-30 axes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 5, 6, 7, 8, 9, 10, 11, 12. Connect them. A, B, C, D, E, F, G, H. Connect all these points. You get an ellipse. What is this? This is the isometric view of the circle seen in the plan. Isometric view of the circle seen in the plan. This method which you have adopted is called the point method. Point method. I named this point method because we have got another method to draw this. Another method to draw isoview of circles seen in elevation and the plan, and they are called 4 center method. We use 4 centers to draw 4 arcs with your compass. Therefore, that method is called 4 center method. This method is accurate. This point method is accurate. The position of the points are exactly correct. But when you draw with the smooth curve along with your free hand, there is high probability that you lose the shape. You have to be very careful while drawing this smooth curve. This difficulty can be overcome in the other method which you call as 4 center method, because you are drawing 4 arcs with the help of a compass. So 4 arcs with 4 centers to draw the get the curve with the help of a compass. But the problem is, even though the drawing will look good, there is a problem of accuracy in that. Some points are not in the correct position. There is accuracy issue, there is some reduction in the major axis of the ellipse. That's a problem. However, that is mainly used to draw fast, and a little bit of inaccuracy is permitted also. But in certain problems, if you follow four center method, you will land up in total trouble. You will know it only after finishing the drawing. I will inform you which are the places where four center method cannot be used, and those issues that are arising under such circumstances. I will point out. I will discuss them in corresponding problems. Okay. So we have drawn iso-views of circles seen in elevation and plan using point method. We will draw them using four-centered method, and then we will pass on to isometric views of solids. These are isometric views of plane surfaces. Then after completing this, we will go to isometric views of solids. Now let us draw isometric view of a circle seen in elevation. A circle 60 mm diameter, 65. You are going to draw isoview of a circle 60 mm diameter seen in elevation. Circle 60 mm diameter seen in elevation. That's what we are going to draw now. What do you do? Draw a rhombus. This is a rhombus. When you draw the when the 30-degree axis and coming, you get a rhombus. Draw a rhombus with 60 mm side. Okay? Slightly different. I call this 1, 2, 3, 4. What is 1, 2, 3, 4? 1, 2, 3, 4 is a rhombus whose side is 60. Okay. Join the larger diagonal. This is the larger diagonal. Join the larger diagonal. These two are obtuse angles, these two are acute angles. Find the centers of the sides. Join the obtuse angles to the centers of the opposite sides. When you do that, you get 2 points here. I call this A, B, C, D, the centers of the sides, and I get E and F here. You need not draw 3 lines to get an intersecting point. You can draw only 2 lines to get an intersecting point, but for symmetry appearance, I have drawn all the lines. That's all. Now, after getting these points, with 2 as center and 2C equals 2D as radius, draw an arc between C and D. 4 as center, 4A equals 4B as radius, draw an arc between A and B. F as center, FC equals FB as radius, draw an arc between B and C. E as center, EA equals ED as radius, draw an arc between A and D. What do you get? You get an ellipse. A beautiful ellipse, right? And this ellipse is nothing but the isometric view of a circle seen in elevation. Agreed? Now, I repeat the procedure. Draw the rhombus, draw the larger diagonal, join the obtuse angles to the centers of the opposite sides. A, B, C, D are the centers of the sides. E and F are the points where the line connecting the obtuse angles to the center of the opposite side meet each other or meet the larger diagonal. 2 as center, draw an arc between C and D. 4 as center, draw an arc between A and B. E as center, draw an arc between A and D. F as center, draw an arc between B and C. Very, very simple. Agreed? Now, let's draw it when the circle is visible in the plan. I draw the 30-degree axis. 2 30-degree axis. 30, 30. We draw the rhombus 1, 2, 3, 4. 1, 2, 3, 4. A, B, C, D. Join the larger diagonal. Join the obtuse angles to the centers of the opposite sides. Same thing we do. 2 as center. 2C equals 2D as radius. Draw an arc between C and D. 4 as center. 4A equals 4B as radius. Draw an arc between A and B. E as center. EA is equal to ED as radius. Draw an arc between A and D. F as center. FB equal FC as radius. Draw an arc between B and C. You get an ellipse. So this is iso-view of a circle seen in plan used or drawn using 4-center method. 4-center method. As I told you earlier, 4-center method is quick, but there is some accuracy problem in this, which we will see in the subsequent problems when we draw circles. Agreed? So we have completed isoviews of plane objects. In the next video, we will go to isoviews of solids. Okay? Thank you.